In this video, I will show how to set up an integral to find the volume of the solid of revolution using the cross-sections method. So let's get started by drawing the region R. And the region R is in between the piece of the parabola y equals x squared and the piece of the sideways parabola y squared equals x on the interval from 0 to 1. And we're rotating this region around the horizontal line y equals 1. So we'll get a picture something like this. And the solid of revolution will look something like this. And if we're using the cross-section method, first we have to figure out which cross-section are we going to consider. Perpendicular to the x-axis or perpendicular to the y-axis. It is pretty clear that the cross-sections perpendicular to the x-axis will have the same shape, so we will be integrating with respect to x. Now in the cross-sections method, what we're integrating is the area of an arbitrary cross-section defined by value x. So here goes the area of such cross-section at some arbitrary point x. So let's pick the point x. I already got one over here. And let's draw a typical cross-section. So it will look something like this. So if we take this cross-section out and sketch the graph of it over here, we can see that it's a circle with a hole. Now the thickness of this cross-section is dx, but it doesn't matter because we're looking for the area, and the area of the cross-section can be found using the formula pi r squared, where r is the radius of the outer circle, minus pi little r squared, where little r is the radius of the inner circle. Now we can trace this radii back to the original diagram. So what is little r? Little r will be the distance from the axis of revolution to this graph. And this graph is y, it's the graph of y equals square root of x. Big R will be the distance from the axis of revolution all the way down to here. And this graph is the graph of the parabola y equals x squared. So the area of this circle with a hole will be equal to pi big R squared. Big R squared is, again, the distance from the axis of revolution to the graph y equals x squared. And little r will be the distance from the axis of revolution to the graph of y equals square root of x. So we're going to have the following result. Now, this is my area of the cross-section formula with respect to x, and this is exactly what goes as an integrand into this integral that we're creating. Now pi can be factored out, and inside we left with 1 minus x squared minus 1 minus square root of x quantity squared. And finally the limits of integration are from the lowest value of x to the largest value of x, which are 0 and 1. So this is the integral that finds the volume of the solid of revolution defined by this region R.